My dear friends, today our article is how we can derive a formula for magnetic field at a point inside of a current carrying solenoid or current carrying coil. Okay, I'm having a coil. This is a coil of very large number of turns and current is flowing through it. Current flowing this side. I'm interested what is the magnetic field at any point inside. What is magnetic field at the end? What is the magnetic field at this end of the solenoid? Before going to discuss this article, my dear friends, you to remember a formula of if you are having a loop or a ring in which some current is flowing, then what is the magnetic field at here on the axis? At here on the axis. Radius of the ring is A. Distance from here to here, let it is x. This formula is B is equals to mu naught upon 4 pi 2 pi I 2 pi I A square upon A square plus x square raised to power 3 by 2. How this formula comes? How we know this formula? The question is how this formula, from where it comes? The question is how we can know about this formula. No problem. You go to my previous video. For the heading of the video was what is the magnetic field at a point on the axis of a current carrying loop. In that video I explained, in that video I derived this formula. But if we are interested for a solenoid, if you are interested to drive an expression of magnetic field due to a solenoid, then you to remember this formula. Otherwise, there is no chance. Okay. Now, I represent this coil or the solenoid like this. The dots mean, the dots mean the coil, the end of the coil is coming out to the paper, mean it is coming out. And here cross mean the end of the coil is going into the paper. This is point mean out, this mean cross mean in. This is an insulated wire. Let it is an insulated wire. And you are interested for making a solenoid or a coil, then you will give this type of rounds. This type of rounds. Now what will happen? Like if this is a plane, and it is coming out. Then we represent it by the dot. Okay, dot going into mean cross. Now the problem is, what is a magnetic field? Problem is, what is a magnetic field at a point on the axis of the solenoid? So length of the solenoid is capital L, right? Now this is, this is my observation point. Now I define N. N means number of turns per unit length. I consider a very small section of the solenoid, very small portion of the solenoid, and the width is dx. Now what is the number of turns in this width? Very simple, n into dx, number of turns in this width. Okay. Now from here to the observation point, the distance is x naught, and let this distance is x. Then what will be this distance? Very simple. It is x naught minus x. Okay. Now in terms of angle, this is the observation point, and this is the end, one end of the solenoid. So let this angle is theta 1. Okay, and this is the other end of the solenoid, and this angle is theta 2. Right? Now a small portion of the solenoid is making an angle theta. Now from here to here, this distance is r. This is the radius, small a. Now writing here the cotangent theta. It is base over the perpendicular. And what is base? This is a baseline. It is x naught minus x. And what is perpendicular? It is A. So this is our cotangent theta. Okay. Or you can say x naught minus x is A cotangent theta. Now differentiating, x naught is constant. So minus dx is A cosecant square theta into d theta with negative sign. Because cotangent theta differentiation is minus cosecant square theta. Now minus and minus goes. So we are having the value of dx, and writing here the sine theta. Sine theta is what? Perpendicular over the hypotenuse. And you know very well, or you can say from here, r is equals to a upon sine theta, or you can say r is equals to a cosecant theta. So this is the value of r, this is the value of dx. Now I am writing magnetic field here due to this section of the coil or solenoid. What is field at here? What is field at here? Due to this section of the solenoid. By using this formula, right? Very simple. I will write here like B equals to mu naught over 4 pi then 2 pi I a square, because in my case the radius of the solenoid or this portion of the coil is a. And moreover, because this is a formula of field for one loop. Now how many number of loops I am having here? Number of loops there n dx, n into dx. I have to multiply this by n dx divided by this a square as it is. Now instead of x, I am having this distance. I am having this distance from here to here. This distance is x naught minus x. So x naught minus x whole square. Okay. Now you know, using Pythagoras theorem, r square equals to a square plus x naught minus x whole square. And here it is raised to power 3 by 2. So 3 by 2 comes here. Now instead of writing this, I am replacing it with r. So B becomes mu naught over 4 pi 2 pi I a square n dx r square and power 3 by 2. 2 and 2 cancels. It is only r cube now. Now the next point is I am having value of dx. I will substitute this value at here. Okay. I am having this r value a cosecant theta. I will substitute this value here. So then B becomes mu naught over 4 pi 2 pi I a square n. Now what is dx? Again a cosecant square theta then d theta divided by, this is r cube. R cube means a cube cosecant cube theta. Now what happens? A square and A, it is A cube cancels. Cosecant square theta cancels with cube, left power only 1. Now this B becomes, or not B, small magnetic field. Why small? Because I consider small portion of the solenoid. This is small magnetic field dB. So dB equals to mu naught over 4 pi 2 pi I, okay, and N, then 1 over cosecant theta, because cosecant power 1 over cosecant theta is sine theta, and d theta. So this is what we left from the expression, small magnetic field. Now our problem is magnetic field from this end to this end. I have to integrate this expression, and what will be the limits? Theta 1 to theta 2. In this end to this end, theta 1 to theta 2. So theta 1 to theta 2. Field becomes mu naught over 4 pi 2 pi I n. Sin theta cos theta integration is minus cos theta. Minus cos theta limits theta 2 to theta 1. Because minus cos theta, so that's why it becomes cos theta 1 minus cos theta 2. Because of the negative sign of sin theta is minus cos theta. That's why theta 1 comes first. So this is the expression of magnetic field of this solenoid. Now I consider a special case. This is the formula of magnetic field due to the long solenoid. The length in terms of the angles theta 1 to theta 2. Now this was my solenoid and this was the axis. Here was my observation point. And angle, this was theta 1. This angle was theta 2. Now a special case. If my point is, observation point is at this end, and the solenoid from the other end it is infinite long, then what happens to the magnetic field? Okay. Now if this point comes here, what happens? Theta 1 increases. If it comes here, it increases. If it comes here, it increases. If it comes here, it becomes 90 degrees. So theta 1 goes to 90 at this end. Now if the length of the solenoid is increasing, theta 2 increases too. If it is of this length, then still more increasing theta 2. And ultimately, if this length goes to infinity, that means theta 2 goes to pi, because it is increasing, then it goes to pi. When it goes to infinity, length goes to infinity. So the formula for the field becomes mu naught over 4 pi 2 pi ni cos theta 1. Theta 1 is 90 degree and cos 90 you know what? Cos 90 is 0. Then minus cos theta 2. What is theta 2? Pi. Cos pi is minus 1. And minus minus becomes plus. So it is 1. So pi cancels, 2 with 2 cancels. And answer becomes mu naught upon 2 ni. So this is when, point lies here at one end, and from other end it is infinite long. Now again you think this is a solenoid and this is the axis. This is our observation point. If it is going infinity along this side, then I already explained theta 2 becomes pi. Similarly, if it goes to infinity along this side, then what happens to theta 1? If this is the end, this is theta 1. If this is the end, theta 1 decreases. If this is the end, it is still further increasing theta 1. So if it becomes infinite long, then theta 1 goes to 0 degree. Infinite long along this side, 0 degree. Infinite along this side, pi. Substituting this condition here, the formula becomes mu naught upon 4 pi, 2 pi ni cos theta 1, cos 0. Theta 1 is, what is theta 1? Theta 1 is 0. So cos 0 is, what is cos 0? Cos 0 is 1. Minus theta 2 is pi, because infinity along the second end. Cos pi is minus 1. So minus minus 1. So this is 2. And 2 and 2, 4. 4 cancel with this, pi cancel with this. And B becomes mu naught ni. So this is the formula of magnetic field. At a point inside, at here, due to the long solenoid. And what is this formula? Mu naught ni. Now a last question for you. If this is a solenoid and this is the axis, you have to find field at this end. And it is infinite long along this side. You just check about what is theta 1, what is theta 2, and what about the expression of the magnetic field. If you find the correct answer, write me in the description box. Okay, if you like the video, thank you very much. If you like the video, then please subscribe my channel. Okay, thank you very much.